This is going to be a quick review of writing your answer in exact form when you're doing a quadratic formula problem instead of getting the decimal answers. So imagine you're solving the problem x squared minus 2x minus 2 is equal to 0. If we start doing the quadratic formula, our a value is a 1, our b value is a -2, and our c value is also a -2. So we'll fill in our quadratic formula, x equals opposite of b, so a positive 2 plus or minus square root b squared minus 4ac all over 2a. Start with the numbers under the square root and make this calculation. -2 squared is 4, and -4 times 1 times -2 turns into positive 8. So we end up with the square root of 12 all over 2. So this is where you would typically go to decimal answers. You would have in the past done 2 plus the square root of 12, pressed enter, and divided by 2, and then 2 minus the square root of 12, and pressed enter, and divided by 2, and gotten those decimals. Instead, we're going to simplify this square root into exact form. So what we do is we look at the square root of 12, and we try to break it apart into its factors. 12 is 4 times 3, 4 is 2 times 2. So if we're thinking about square roots, the square root of 4 is 2. The number we don't know the square root of is the square root of 3. The reason we write the 2, and it's only once, is because the square root of 4 is 2. We see this pair of 2's as a reminder that that's what we should have as a coefficient out front. So back in our quadratic formula, we are going to replace the square root of 12 with our simplified radical. So it's going to say x equals 2 plus or minus. Now we're putting in our 2 square root of 3 all over 2. The last step is to reduce your fraction at this point. The number inside the square root never gets divided. It's attached to the coefficient of 2. So the 2's get reduced and the 2's get reduced. You can write the 1's if you prefer. They're not necessarily required, so we've got 1 plus or minus the square root of 3 as our final exact form, and it's called simplified exact form. We'll do one more example. So now we'll solve 2x squared plus 4x minus 8 is equal to 0. So if we start from our quadratic formula, x equals -4 plus or minus square root 4 squared minus 4a and c all over 2a. Start with the numbers inside the square root. 4 squared is 16. 4 times 2 is 8. Times 8 is 64. And the negative makes it positive 64. So now we're at x equals -4 plus or minus. And inside of our square root, we end up with 80 all over 4. Don't go to decimals yet, although on your test or essential skills test, yes, you can write your answer as a decimal. That's safest. I would recommend doing decimal answer and attempting the simplest form because they'll require that for algebra 2. So we start with the square root of 80, break it apart. 8 times 10, 4 times 2, 2 and 2, 10 is 2 times 5. So all these numbers, like 8 and 10, that could get broken apart farther, those are not involved. We're only looking at these prime numbers at the bottom, the 2's and the 5's. So really what we have left is a 2, a 2, a 2, a 2, and a 5. So if you multiply 4 2's together and a 5, you'll get back to 80. So now we're thinking about square rooting these. And so you're looking for those pairs. Well, a pair of 2's, that's because that was 4. And the square root of 4 was 2, just like we saw up here. We've got another pair of 2's, which multiplied to make 4. And the square root of 4 is 2. So any number that's paired, if you represent it once in your answer, we still cannot square root 5. So we go back to our quadratic formula and we replace that square root of 80 with this. 2 times 2 is 4 times square root of 5 all over 4. Oh, this is another one where the 4's cancel out. Okay, we're going to divide by 4 here, divide by 4 here. So negative 4 over 4 is negative 1, plus or minus. 4 over 4 is 1. It's optional to write that. And the square root of 5. It's okay if you don't feel like a master of this yet. A simplest exact form is not a requirement until Algebra 2.